Hi, my name is Zachary Angela, and I'm going to be going over sort of how I start Go and uh, just sort of how you would start a project and get things going. The first thing I do usually is create a main.go file, and I'm using VS Code. So it has some little shortcut things to kind of get things going. You This is basically the package name. You could kind of think about it in other languages like username spaces, but in Go, you have to state the package, and so the code is scoped off to that package unless you import the package. You have your main function, kind of like you do in some of the other languages, that kind of initializes things. And then, in order to print something out, just to do something really easy, you do print ln for line, and you just print out whatever it is. And a lot of times I'll actually go into here and download the Go extensions. They have all different kinds, like Go Nightly, Go, different things. Because you notice when I type this in, it automatically imported this, and that's sort of part of what some of those Go extensions do. If you just download some of them, you'll pretty much get that. Um, so, anyways, you create a file. Well, you've installed Go, which is on the Go website. It's really easy to do. But you have the file, you make a print, you do like a hello world thing, and then in order to run it, you don't need some special extension, you don't need some special library, you don't need some special framework, none of that. It's just that file, it's just the language, it just runs. In order to run it, you just do go run. You could do main.go and it'll run it. Go run. If you're on Linux, which I don't think it does this on Windows Bash. Yeah, I didn't think so. But on Linux, you could do asterisk.go. Um, I'm sure there's a way on Windows to run all the Go files at one time, but whatever. Um, Another command that's nice is go build. That basically does exactly what you think, but you need to have a Go mod file. What's a Go mod file? Well, the Go mod file is basically, Python and some of the other languages have this kind of dependency file that basically describes them and their versions and so on and so forth. Go sort of takes the approach of the language kind of takes care of dependency cycling and the versioning to a degree, and there's other commands you can do in order to change things, but this is basically all you really need. And so I'll go over how to create the Go mod file. You just go mod init and then whatever the package name will be. Sometimes it's GitHub, whatever. Sometimes it's just a local package. Um, whatever it is you're wanting to do. I could do star. I don't know. Sure. Well, let's just do the name of the folder. It just makes things easier. And it kind of suggests you to do go mod tidy. What does go mod tidy do? It basically runs the command to look through your files to see if are you actually using these dependencies, and if you are, pull down the ones you need. There's also another command, go mod vendor, which creates a folder of these dependencies. Oh, well, you actually have to be using something outside the standard library in order for it to be a dependency inside the vendor folder, because otherwise you have it all in your language that you installed. But that would be how you would pull them down locally, have them into a nice folder. Go mod tidy pulls them down, but the vendor puts it into your projects folder, and then it kind of knows to use those whenever you do like go build and everything. So now that we got that, you run go build, and there's a binary. It automatically kind of knew that you're on Windows and you wanted to create a Windows one. If you're on Linux, it'll do the Linux version of the binary. You can run different commands to create a Linux binary on a Windows machine, vice versa. You could look that up. It's one liner right in the command line. It's really easy. I don't use it a whole lot unless I need to. But anyways, so you could either again do go run main.go, or you can do the binary and it'll be the same thing. Um, for people that don't know, it compiles down the machine code. That's why it creates the binary. There's no like JIT or some kind of in-memory language thing that it tries to deal with. That's why it seems so fast. And the key is that it'll stay that fast pretty much no matter how big the code base gets. Which is really nice because let's say you're building a big CLI app that just keeps growing and growing and growing and growing. You just keep running go run main.go or whatever it is, and it just automatically runs it. It's nice. Um, so, okay, you have a file here. You printed out a string. Now you're like, okay, well, I'm sure there's other stuff, and there is. Um, Variables are basically how you think. Um, you put the data type in front of it instead of before it. It will complain because you haven't used it, and you do need to add a value to it. I don't, well, maybe I just print out nothing. Yeah, so it's a zero value. So I guess you don't necessarily have to put a value in, but you do have to use it. So how do you put a value into it? You just do guy equals whatever, and whatever. So okay, you have that, easy enough. Now what do you do? Well, you can create a function. Just do func, whatever the name is, the parameter thing, and then whatever you want to put into here. Want to take this, put it in there, or whatever. It's basically like other languages. There's no weird thing going on. You run it, and boop. Let's see, what else would you try to do that you could have the function return stuff, and so you want to return a string. Just do return guy, and this basically means it's returning whatever you put into here is what it would get. So if you wanted, I don't know, g some random, this is basically an alias for whatever's going to be used in here. And so let's say you were just going to put something in there. That's basically like the same thing as what we did, but it's more inside the function, I guess you could say. What's another thing we can do? There's loops. There's only the for loop. For, if you did this, it would run forever because there's no, I equals 0, whatever the loop is. It's basically the same thing as other languages. This right here is basically just saying keep that to the scope of this actual thing. If I did this and here, it would be only within the scope of this function then. The value would only be alive within the scope of that syntax or whatever you want to call it, the function, loop, whatever. But if we did this, it would be an infinite loop, and so you would just do, run, sure, And so this will run it forever. Hey, um, I don't think I need to show you what a for loop is. It's really easy. If you need to get examples, a good website is Go Buy Example. And this goes into slices and arrays. And slices are basically, in other languages, they tend to only allow you to do it to arrays. In Go, you're able to do it to strings. I don't think integers, but you could do it to same old stuff like maps, arrays, whatever collection you can think of, bytes, whatever. The only thing is you do have to worry about with slices is it sort of does create another array underneath it. So if you're going to be slicing stuff up, there is a bit of allocation. Um, but slices are fun and neat. And in order to test this out, you can just hit the little gopher guy and you can hit run here and it'll take you through what's going on. But in essence, this 2 is starting from the second part of the array. It's like that in other languages. And if you wanted to change things up, you could have the first 2 and then have it go all the way up to the 7th part of the array. Whatever it is. Obviously, there's not 7 parts of the array here, but you get the idea. It'll tell you right away, hey, you goofed up. So, hey, you have the switch, which, I mean, it just looks just like other switches. Um, range, which is kind of exactly what it sounds like. You're ranging over the exact characters. It's like in JavaScript or whatever with for each. Yeah, you can have multiple return values, variac functions, which just means a function that equals a variable. Let's see. Yeah, it is the dot dot operator, so you can add in as many parameters as you want. Go routines and channels. These are things that are more for when you want to make the thing parallel or concurrent. But if you're just starting out, it's really not something that you should be all that worried about. I'd say, well, structs are a good example of just a data structure. Think about it as like a variable or like an array, but it's structured. So if you just do type, you know, guy, and then you do the type struct, and then this is where you would put in name, string, age, and whatever it is. And then to use this puppy, um, you would have to make it equal like a variable of some sort. So let's say gg equals guy, and then you set up these curlies to sort of mimic this, sort of, in a sense, kind of. And see if you hover over it, basically says what is needed. And you just do name, and then you do semicolon, and then whatever the value that you're going to be initiating, and then comma between them. And that's really it. And then this thing is equal to all of this. So if you, let's say you want to print this out, but see how this is taking in a string, not a guy type guy struct. You would just do guy, and then it gets it. This obviously won't work because that's a string, but that would be how you would pass all this stuff in. The only thing is you'd probably, well, it might print out the whole struct, not each thing. So if we run it, yeah, type string and return. Oh, because I didn't. There we go. You're gonna run into a lot in the TypeScript language, but yeah, that basically prints out those fields. If you want to print out individual fields, you just do that. And what do you know? I mean, you literally could have just kept this and then just did that name, and that would be basically the same thing, so it just prints out the name. Um, you can also nest these. Um, so you can, let's say you have, and this is kind of like Go's ability to do inheritance. Say she, I don't know. And you can put she down here. And that is a type that's in there. It's not used though. So I believe it's something like this. Sometimes I gotta look up exactly how you nest out things, but um, wait. Da, 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 da. No, wait. I think it's gotta be she. Yeah, there we go. Yeah, I remember it was something a little different, but yeah, that would be how you would nest it. And well, no, because I got the name thing here. So we did this. There you go. It's sort of like inheritance in a sense, kinda. You know, if you did cat, dog, whatever you wanna do, that would be how you would do that. Um, there you go. Oh yeah. Um, Pointers, they are considered their own type. So when you do a pointer, which is just this asterisk, this thing is not the same type as something like this because it's a pointer to a value type. It's its own type, which I know sounds a little weird and confusing. You don't have to get too far into these pointer things. It's not, I don't know, I think it just complicates things, and it's good to stay away if you can. But that's what you got to know is that so when you, let's say you pass it into here as this, uh, so let's say you have this and you want to pass this in, you couldn't pass it in like that because that's a completely different type than this. Even though you're using this as the pseudo name to here, and then you're doing a pointer to it, uh, this is a different type than what this is. So you have to kind of understand that, um, or what, or rather, I'm sorry, what this is, because this is a pointer to this, which is a pointer type. So let me see. Will it tell you undefined? Oh, because you didn't make the type up here, basically. Well, let's see. Sometimes I get confused myself with pointers, kind of. I don't really use them a whole lot, but if we did that, should print out the memory address. See, type cat is type pointer. It's not the same thing. Um, so I believe you remedy that. I think cab is argument to run. Well, they got to be the same type. Pointer to cat. I could have sworn you would do the ampersand in order to get it. Yeah, I get really confused with pointers. I just don't use them that much. One. Now, if you did this, I try and figure out zero type int as type. So this has to be a pointer because this is a point int. But what happens if you used a custom type here? Would that necessarily mean the same thing? Did they do any struct? No, they didn't. Let's say name or string. This ain't inside of a function. Let's say you initialize this name struct. And then let's say you pass it into here. Sometimes I just try it out. Point int. So if you had age 3, oh yeah, I gotta change the actual struct. Oh, did it reset it all? No, it didn't. Okay, good. So that worked. I think because you're not actually moving the type. Oh, because you're making it a pointer as soon as it gets in by doing this. Because you're referencing the pointer, but when you're actually doing the pointing, that's the value. Okay. I had that confused. You don't have to get that far into pointers, but yeah. I think they just make the world a lot more complicated. Methods. Oh yeah, methods too. So you basically have your type here. You get the pseudonym. And well, you don't have to do a pointer to it, but and then you do your method name right here, and that's basically the name of this method that's gonna be put on this object or struct, and then it's just what you return. And so when you call this, it's on that pseudonym of that struct. Hopefully it's not too complicated for you. But it's just a way to call a method while referencing the type you want to put it on. Basically, that's it. Interfaces, they're usually in other languages, they're just there to say, oh, you have this certain property or whatever. In Go, you do it by only methods. This is just its return. That doesn't mean, well, I mean, that whole thing is the method signature, but the interface really only cares about the method that you're putting inside of it. Because this is an interface, and so somebody put some methods in here, and so you get to use this interface as its own type then. And so when you pass this in right here, because they created a method measure, and you're passing in the type interface, it just means that whatever type has that same method as these can be passed into this function. Hopefully that wasn't too confusing for you, but it just means, hey, does the contract, what are its terms? Oh, right here, does it have these? Okay, well then you get to go into this function. There's other stuff too, but I mean, for right now, it's all you really need to know to kind of get going. Okay, so what can you do with all this? A lot of times what I do is I'll kind of get into more packages Some useful ones I like a lot are like Go Cobra for CLI stuff, and I believe I made a video thing on that. And so you get to kind of create CLI tools through using this code. Um, Another one, there's also the Go Viper, but they're somewhat intertwined. But that would be an easy way for you to create a CLI thing to like generate code or something like that. Um, I made another video where I talk about Echo, which is kind of a web framework thing. It's basically there so you could easily serve pages. May look confusing now, but it's actually um, relatively easy to kind of get your head around. Um, it You can create your own functions. You just got to pass this into them and return error. And basically, you could, well, this just would return a string on the screen. And this is the route that actually gets set up. So you'd have to visit /hello, and it uses that method in order to return that string on the screen. You could also put parameters so that um, you can actually draw data from the URL that the user visits. Um, you can have it serve pages, check passwords, do all that fun, neat stuff that you could go through on here. More stuff that I usually do. Like I said, I usually use it to like generate code and create web servers, and that's and CLI applications. That's generally what I use it for. Um, yeah. Um, I created a resource that sort of goes over and has a lot of different packages and things to kind of learn and just trivia stuff, and it's 52 pages worth of every little thing you could possibly think of that I've picked up over the years with learning Go. Um, yeah. Um, I'll link this stuff in the video notes. But yeah, that's generally what I do with it. Um, Doing like a little server thing, like if you don't know what a server is and you're just new to it completely. They have like this would be kind of an example of, and I'll just well I'll make another video. I'm sure it is long enough about how to set up a web server. Um, but if you need anything else or you have any questions on this, just let me know. Um, and yeah, I'll leave all the notes in the video. Okay, thank you very much.